So before we get going and working out calculations and concentrations, we've got to just remind ourselves what we mean by what a solution is. Okay. Very simply, a solution is when we've taken what we call a solute, so it might be a solid lump of something that dissolves in water. We've chucked it in to some water, which is in this case, well, we chuck a solute into the solvent, which in this case might be water, and then what we end up with is the solute dissolved in the water, and we call that a solution. I want you to get a sense of what a solution is. If you want to know what happens when something dissolves, we can talk about that more, but there's a really fantastic video on watching a crystal of salt dissolves. If you just look up crystal of salt dissolving, as a little video, it gives you a sense of what's going on. But essentially what happens is all the particles that are in the solute, when they go into the water, they break apart from each other, and each one of the particles that made up the solute gets surrounded by the solvent molecules to make the solution, right? So that each of the particles are now independent, floating around, moving around, which is why when we have an ionic solution, it can conduct electricity, okay? But in chemistry, we've got to think quantitatively about solutions as well as just qualitatively. And we have to understand how to calculate concentration, and I've shared this worksheet with you, which hopefully you can see, where we just start ourselves thinking about concentrations, right? So we're going to work through some of these, but before we do, I'm just going to tell you a couple of things. So the concentration can be measured in grams per decimeter cubed, and it can be measured in moles per decimeter cubed. We're going to think about those two things separately. So the concentration in grams per decimeter cubed is equal to the mass in grams divided by the volume in decimeters cubed, right? So that's the equation, but you know that intuitively. I think you know that intuitively, how much is dissolved in a certain volume. So the fact that the units are grams per decimeter cubed, per just really means divided by. Grams divided by decimeters cubed. That's all you've got to remember. So miles per hour, miles divided by hours, right? We might also, as I said, for triple award, have to work out the concentration in moles per decimeter cubed, and that must be moles divided by decimeters cubed. So it's the amount in moles divided by the volume in decimeters cubed. Okay. Now, sometimes in chemistry we might be given the volume in centimeters cubed, and it makes sense always to convert to decimeters cubed. Remember, 1 decimeter cubed is equal to 1,000 centimeters cubed, and that will become important as we start doing titration calculations shortly, or probably in a lesson or two. So what we're going to do is just think about how we can rearrange those equations and link those equations together by doing some examples. So let's go up to part A in the worksheet and see if you can do it in your head when we do a few of these. But we've been told we've got 2 decimeters cubed, we've got concentration of 1 mole per litre, so we've got to work out how many moles there are. Okay, so the thing you've got to do is to take this equation and rearrange it, so we can say the number of moles is equal to the concentration times the volume. We're going to use that version of the equation an awful lot as well, so it's worth making a little note of. So try and do it in your head. Number of moles is equal to the concentration times the volume, and the concentration is equal to the number of moles divided by volume. They're the 2 most common ways we'll use it. So 2 times 1 is equal to 2. That's all you've got to do, moles. It's the same down here. We're going to use concentration is equal to number of moles divided by volume. 10 divided by 2 is equal to 5. And then you can have a work through part C as well. If you can rattle through that, That'd be great. We'll check what you've done in a sec. And go back to this sheet then. So well done on tasks A to D there. And I told you, didn't I, that we might need to convert from grams per dm cubed to mole per dm cubed, or vice versa. So let's think about how we do. That. So we know that the number of moles is equal to the mass in grams divided by the formula mass, right? And so to get from, if we want to turn mass into moles, we divide by mR, don't we? If we want to go from mass to moles, we divide by mR. So the same thing applies here. If we want to go from grams per dm cubed to moles per dm cubed, we simply divide by mR. We also know that mass is equal to the number of moles times mR. In other words, if we want to go from moles to mass, we multiply by mR. So that's how we go about the conversion in the other direction, and you'll need that when looking at the next worksheet, which is called concentration of solution. So refer back to that in a second, and you're going to be working through this sheet next before we start talking about titrations. So you might just have to initially work out for the first few questions the number of, or the concentration using this equation here, or number of moles using N is equal to C times V. Be really careful though here, in these, be really careful because the volume is given in centimetres cubed as it often is at GCSE. So you might need to convert, or you do need to convert to decimetres cubed first by dividing by 1,000. So it's 0.1 decimetres cubed, 0.025 decimetres cubed, or 0.5 decimetres cubed. Or you could simply write it out as I like to do, N is equal to C times V over 1,000. And that converts centimetres cubed into decimetres cubed for you. So that's the other way of thinking about it. I don't really mind what approach you take. But where it gets a bit more difficult is over here. We need to convert mole per decimetre cubed into gram per decimetre cubed using the equations we just talked about that are also written there. And likewise, work out something in moles per litre, convert to grams per decimetre cubed, and vice versa. Okay, so can you have a go? Questions 1 and 2 are like what we've already done, with just the added complexity of dividing by 1,000. Question 3, you'll need to convert a little bit as well. So have a little go at those, please. On you go.